Okay, so we're starting chapter 11 today, and we'll be doing chapter 11 the remainder of the time here. And we take it slow, so when you have questions on homework, you need to just make sure you ask the questions, because it would be really, really, really easy to get behind in this stuff, but we're going to take it slow enough where no one should get behind. So if you have questions, just ask. When you're doing homework, we'll have a lot of homework days too, and we'll be assigning a lot of homework on this stuff, because the only way to actually be good at this stuff is do a lot of problems. And this stuff, like chapter 11 stuff, is all over the BC test, so you just have to be really good at it. And they put it in multiple choice all the time. There's usually one free response question that deals with your series, so you have to know all of the rules. There's lots of different tests that you can do. I'll give you like a cheat sheet for the tests, but we'll do so many of them that by the end of chapter 11, people are actually really, really good at this, and we end up doing really well on the AP test on this stuff. So just make sure you're keeping up and asking questions. So series, it may be impossible to find the sum for the series 1 plus 2 plus 3 plus 4, because these numbers keep getting bigger, right? So when you're adding them up, what are they going to add to? Infinity, right? So it gets infinitely large, so it's divergent. But if we add this, like the pizza problem here, where we do half a pizza, then a quarter pizza, then an eighth of a pizza, and we keep adding them up, we end up with one pizza, right? So that one is convergent. So we can add an infinite amount of terms and have it still converge to a value. This is our summation notation here. So this is saying we're starting with n equaling 1, and we're going forever. So first thing we do is we plug 1 in. Stephen, if we plug 1 into here, what do we get? 2 in the bottom, so we got 1/2, right? Plug 2 in, and you get, so 1/4, and then so on, right? So isn't that rule really like 1 over 2 to the n power, right? And if we add all those up, we know we get 1, because we've done that problem before. This here is one of those things that you might want to highlight. I'll put all the really important stuff on a cheat sheet here for you. But if we're going from 1 to infinity, it's kind of like our improper integrals, where we replace our infinity with a letter, and then we go and we take n as n approaches infinity. And then they replace the n's in here with i's. So they're just replacing letters is more or less what they're doing. But you're replacing your infinity with the letter, and then you're letting n go to infinity. So it's just the notation for it. All right, so problem here. If we know the sum of the first n terms of this series is this. So this is our first n terms. And it says it's going on forever. So what we're going to do is we're going to replace this forever with what? An n. So we're going to replace that with an n, and then we're going to take the limit as n goes to infinity, okay? So we're really just taking this piece here, and we're just taking the limit as n goes to infinity. So that's what we're going to write here. So we got our 2n over 3n plus 5. And how can I take that limit efficiently? You can't split it when there's two things in the denominator. What? So if we try to plug in infinity, we get infinity over infinity. So you can use L'Hopital. So that's one way to do it. So you can say it's infinity over infinity, therefore L'Hopital's applies. So if we apply our L'Hopitals here, then we get the limit as n goes to infinity. What's going to be on top then? 2, and on bottom 3. So we just end up with 2/3. So that tells you the sum of this series here, okay? The other way you can do it, and you might just want to practice both ways, because sometimes L'Hopital's is super efficient, like when it's linear, because when you take the derivative, it's just linear. But if these are to a crazy power, then doing L'Hopital's, you'd have to do it over and over. So the other way that you can do this is divide everything by what? And you divide by the highest power in the denominator. So n is our highest power. And if you divide everything by n, so I'll just write a little note here, divide by n, then you just get your limit as n goes to infinity, and we just get 2 over 3 plus 5 over n. And then what happens to that 5 over n? It goes to 0. So you should get the same thing no matter which way you do it. And you should be able to do those type of things pretty efficiently. So sometimes L'Hopital's is super quick and easy, and then sometimes L'Hopital's would take forever, so then you want to remember that dividing one, okay? So questions on page 1? Okay. Okay, here, this is probably the easiest thing in this chapter are the geometric series. All you have to know, and if it says to actually find the sum of the series, most of the time they're geometric. So if it's asking you to actually find the sum, a lot of times they'll ask, is it convergent or divergent? And then we could use any of the stuff that's going to be coming up. But if it's asking to find the sum, typically it's a geometric series. So if it's a geometric series, then you know the sum is this. And that's just for geometric. And what it means to be geometric is you start with a number, and then you times it by r to get your next number, and then you times it by r again to get your next number, and so on. So there's that common ratio. So if your common ratio is less than 1, when you do the absolute value of it, then it's convergent. If it's greater than or equal to 1, so if the numbers are getting bigger and bigger and bigger, then it's going to be divergent. So when you are given something like this, find the sum, first you have to figure out if it's convergent or divergent, because sometimes it just diverges and you can't find the sum. So to find our r value, we're just trying to figure out what we're multiplying by to get from here to here, or here to here, or here to here. So what are we multiplying by each time? Two-thirds, and it's actually what? Negative. So negative 2/3 is my r. So if I do the absolute value of r, is it less than 1? Yeah, so we know it's convergent. And then to find the sum, we just use this here. So our a is our first term. So what's our a value? 5. So to find our sum, we just do 5 over 1 minus, and then my r is negative 2/3. So don't forget the negative there. And then just, reciprocate your denominator after you get it. You guys getting 3 for an answer there? Okay, and it said find the sum, so we found our sum. Just make sure that it's convergent before you find the sum, because sometimes your r value is like 3/2 and you can find a sum, but it's not accurate. Okay, it's got to be convergent before you actually find your sum. Okay, and over here there's a book way and there's a rabbit way. I'll show you the book way to do this. What the book does is they try to get this to look like this. Okay, and it's important to see it the book way because sometimes they write things, differently on the AP test, or you'll see them like this in college, and it's good to be exposed to it before you get there. So let's start with just what's in here. We're just looking at our piece that's in here. So start with the 2 to the 2n. And some of this stuff will come up in later lessons where we'll use these like algebra tricks to clean things up or write them a different way. And we're trying to get this to look like the a times r to the n minus 1. Okay, so we're trying to get this to look like that. So first thing I can do is 2 to the 2n would be the same as 4 to the n. And then I'm going to try to get this 3 to look more like that. So 3 to the, if I write n minus 1 here, what would I need out front of it? A negative. And then it's starting to look like that. And what I'm going to do, because it's a negative exponent, is I'm going to move it down to the denominator. So then I've got 3 to the n minus 1. And it still doesn't look like this. We want to get this 4, so it's like an n minus 1. And this is something that you'll see in the tests that'll come up later on here in future lessons. If I have 4 to the n, how do I get that to be 4 to the n minus 1? What will I have to multiply that by so those are equivalent? So think about if you have the same base, what do I do with these exponents? Add them together. So how can I get them to add to n? Yeah, it'd just be to the first power, wouldn't it? Okay, so 4 to the n is equivalent to 4 times 4 to the n minus 1. And then if we're trying to get it to look like this still, we can group together these here, and that's going to turn into what to the n minus 1? 4/3, right? So we're going to have 4 times 4/3 to the n minus 1. So what is our r value for that? R is 4/3. So convergent or divergent? Divergent. So is the series convergent? We would have to answer with no, I suppose. Okay, so that's the book way. It's a very, difficult, kind of, especially because we haven't been exposed to it a bunch. This stuff will get actually a lot easier as we keep moving. But then we're going to do the rabbit method because it's better. Okay, the rabbit method is to just start listing terms. Okay, so if we're starting with that and we plug 1 in, what are we going to get inside here? 4. Okay, then we plug 2 in, so we just keep moving up. So 2, I would get 2 to the 4th, which is 16. And then if I plug 2 in here, I get 3 to the negative 1st. So wouldn't that be 16/3 because the 3 moved down? You guys okay with that? Okay, and hopefully, assuming this is geometric, you don't want to assume that because most of them aren't going to be geometric on your AP test. This pattern should continue, so I would plug in the next one. So if we plug in 3, go ahead and do that. I'll give you a second. So I'm here in 64, right? And what's in the denominator? 9, right? Because it'd be 3 to the negative 2nd, which would be the same as 3 squared down here. So it'd be 9. And then dot, dot, dot. And if you look at this, can you determine what your r value is? You can put this over 1 if it's easier. You're multiplying by 4 on top, and you're multiplying by 3 on bottom. So then you can see that your r is 4/3, and you can say it's divergent. So either of those is fine. If you want to challenge yourself and try to do it this way, that's fine. This is going to be the more efficient way, probably, when you get to your AP test there. So questions on that? Okay. Let's do the next one here too. Okay, so write this number as a ratio of integers. I've never seen them put this particular question on there, but it's a good question. You'd almost need to use your calculator to come up with this, so I don't know how they would put this exact question on there. but it does use what we were just doing, so we're going to go through it. So we got 2.317, and the 17 is the only thing that's repeating. So the 2.3 part is not anything that's repeating. So the 2.3 we're just going to leave out front. And then we're going to add what to it to get the first 17? 0.017. And then what would I add to it to get the next 0.17 piece? Yep, we need the 3 holders, right? And then 17 and so on when that continues. So now we need 5 zeros and then 17. Okay, so the part that's geometric here is just this part. This part here isn't geometric with that. And some people have trouble finding what the R is. If you're having trouble finding what the R is, you can find it by dividing a term by the previous term. So if you can't, figure out, okay, I know it's multiplying by 1 over something, like 10 to a power, but I'm not sure what that is, you can always just divide them. So I would just do like the 0.00017 over 0.017, and you can use your calculator to find what that is, or you can move the decimal 5 spots, which gives you 17 on top. And if I move it 5 spots on bottom, I get what? 1700, right? So the 17s they cancel, so do you see how I get 1/100th there? And you can maybe, do that in your head, that's fine. But sometimes you're not going to be able to, so then just remember you can divide. But it has to be, that R value has to be the same all the way through, otherwise it's not geometric, okay? So you could divide another set to make sure that they're the same, and then you'd show that it's geometric there. And what's our A value for this one if we're talking about the geometric piece? Nope, the geometric piece, 0.017. So we're just dealing with the geometric piece here to start with. So if I find the sum of all this geometric stuff, it would be 0.017 divided by 1 minus R, which is 1 minus 1/100th, or 0.01. And then I have to take that 2.3 and add it on to there. Would that give me that entire thing then? And then you could use your calculator from there to reduce that fraction down, or you can do some quick mental math here. So I would multiply the top and bottom by 1,000, and it'd give me 17 on top. And this is 0.99 times 1,000 to give me 990 on bottom. And then I could write this as 23/10, get a common denominator. And if I get a common denominator and reduce it, I get 1147 over 495. Top and bottom divides by 2. But if you typed this in your calculator, you would get, the original there. If you're not getting the original, something went wrong. So, questions? When it says here to write it as a ratio of integers, it's just a fraction. Yep, with an integer on top, integer on bottom. So they don't want a fraction within a fraction or a decimal within a fraction. So they wouldn't want you to go here, Okay. We're going to do this one when everybody's here because it's something that'll show up later. So we do have some homework that you could start, and then tomorrow we'll finish the notes. That's my dog. He's way older than that now. Okay. But yeah, you can start these. If you get to something you don't know how to do, just stop, because tomorrow we'll finish our notes, which actually has a couple more pages. We're going to end up skipping this page here. I think it's still in your notes, isn't it? Okay, we're going to skip that because it gets way too crazy and it's not on your AP test. And then we're going to get to the test for divergence on the next page, which is a really quick and easy test. So this lesson kind of has the easier ones. I would say the hardest thing in the lesson is this one, and it's not like it's crazy hard, but we'll do that together tomorrow. That way everyone's here, hopefully.